Bismillahirrahmanirrahim. Let us look at another form of the question. We are to integrate a function involving the exponent of a power x, e power x, and ln x. For that, we do need to have the formula that we have had earlier. You can refer the formula in your formula list. Alright, so and we will do the integrals using simple U-substitution. Because you can see that the term, the u, for example, is a simple term, u, so we need to do also to substitute. Okay, alright, let's do A. Okay, we start with finding what would be the appropriate u. Okay, and then we are to replace everything into u. So with that, we need to differentiate. Okay, help me. Derivative over 3x is 3, and to replace the dx is du on 3. So let's replace it. We substitute into the question. So this question A now will eventually becomes 2 power u, and the dx is du over 3. Check my work. And before we integrate, do consider to put in front the constant, and we are just to integrate 2 power u du. Right, so refer to our formula list. This is exponent, a constant power u, is a formula number 4. A power u, integrating of it is a power u ln a. So let's integrate now. Using that formula number 4 here. Okay, so check my work. So we get 1 on 3 integrating. So we get the answer, which is 2 power u. So we put 2 power u over ln a. The base of exponent is 2. Right, and plus c. And after you have got that, make sure you replace back your answer in terms of x. So I have replaced the u there, which is 3x, and then we rearranging it. So that will be our final C for this question number A. Alright, okay. Let's do more. Let's compare B and C. So check my work. So we for B, let u be the exponent 1 minus 3x. We differentiate, and then we have to substitute the dx in terms of a u. We rearrange. So after we have got that, then let's substitute. Change everything in terms of u, so eventually it becomes 2 power u. What is dx? Dx is du over negative 3. Okay, and before you consider to integrate, put your constant in front, and there you have the integral of du 2 power u du. So using this formula number 4, okay, we integrate now, 1 on 3, check my work, which is 2 power u over ln a, which is ln 2, plus c, and do consider to change back your u in terms of x. So rearrange it nicely, so that will be the answer for question B. Next, let me do C over here. I have a space here. C, what would be the appropriate u? Okay, the power. Okay, let's take the u for question C being 1 minus 3x. In order to replace dx as u, we need to differentiate negative 3. So dx there is du over negative 3. So we substitute. So this question will become pi power u. Pi is a constant, 3.14 something. There's a 4 there. And dx is du over negative 3. And before you integrate, make sure you rearrange this thing first. Take out the constant. We put in front the constant. So we are left with a constant power u du, which you can easily integrate using formula number 4 again. It's a negative one. formula number 4, a power u. So the answer is pi power u over ln pi and plus c. Don't stop there. Make sure you replace back your answer, the u, in terms of dx. So replace back the u. So that will be the answer for question C. So far we have done A, B, C. Okay, it's fun, right? Let's do more. Okay, let's do D and E. Okay, let's compare D. Okay, so let u be the 3x. We need to replace dx. So differentiate and rearrange. So dx is du on 3. Before you consider to integrate, put the constant in up front. So there we are to integrate e power u. So we have to use the formula of number 5. E power a single x dx is e power x. So integral of e power u du, a single u. So it is e power u and plus c. And make sure that you replace back in terms of the variable given in the question. So that is question D. Alright, okay. Let's do E. Let's do it together. What is the appropriate u? Okay. Should we take the whole set 3 square root x, or should it be just the radical of the x? Here, when you are choosing the u, you would like to get it as a form of e power x single term. So don't leave it as e power 3u, something like that. Yeah? So meaning the u has to be 3 of this thing. So that as we replace it later on, as we substitute it, we have to get that e power a single u, and then replace dx with du. So this is, let's differentiate. So we are to differentiate, check my work. Okay, put it as a power form. And yes, you have to be handy with on how to differentiate. We're going to use a basic formula, r x power r minus 1. So 3 times half, if we have a a there, so if we have a a there, so it becomes a times r. Okay, a times r there. So a times r, so we get 3 on 2 x r, which is half minus 1 we have here. Okay, let's rearrange this. This is like 3 over 2 square root x, right? So we need to replace the dx. What is the dx? Well, over here we have this dx over radical x. So if we are to rearrange it, so we get 2 on 3 of du is similar to the one that I want. Yeah, this one. So this portion du, okay, so sorry, this is dx. So this portion dx over this radical x is actually 2 over 3 du. So let's substitute it. So as we substitute the dx over radical here, okay, dx over radical x there, square root of x is actually rearrange it 2 on 3 du. So we substitute. Before we integrate, make sure that you put up front your constant, and then let's integrate. So we have 2 on 3 integral of e power single x dx is e power x. So integral of e power single u du is e power u. Very good. And don't forget to replace. Okay, so 2 on 3 e power, what is our u just now? That's why you have to take the whole set 3 square root x. If you choose the u to be just a radical x, you will stuck. You cannot integrate. So that will be the final say of our E. Okay. So let's do F. What will be the appropriate U? Yeah, so normally the U is the most inside function, something that is easy for us to differentiate and integrate. So here there's a 2 possibilities. Should we choose U to be 2x, or should we choose U to be 1 minus e power x? Which one? I'm trying to say just now, should I say U to be 1 minus e power x, or should I take the U, or should I take the U as 2 power x? Which one do you think? This one or this one? Okay, I want to try both ways. Let's say we take u so as 2x, see what happens. Because sometimes when we are to integrate, the technique of integration, okay, here we are using U-substitution, but yet sometimes the U-substitution does not work. How do we know it does not work? Because we cannot turn it into one single variable u. Okay, let's say, okay, just for the sake of argument, we take u as 2x because I would like to read e power u later on. So we differentiate, we get 2. So we replace our x dx here, which is du on 2. See what happened? Do we manage to get it as single term u? So we substitute the x into u. Okay, so here we have e power u. Here we have 1 minus e power x, and the x is du on 2. And then you can see that up to this level, we still have e power x. So meaning you are not able to differentiate. Okay, why cannot? Okay, so here you will fail to differentiate because we have two variables there. Okay, you cannot differentiate. Okay, so you are stuck there. So in that case, let's try another one. Let's take the u to be 1 minus e power x. Let's see what happens. Can we substitute everything in terms of a single u? So let's redo it again. Okay, let's erase that and let's try now to read the u instead of 2x. Let's read the u as 1 minus e power x, the inside function, okay, of the radical. So du dx, for that derivative of the constant one is 0. Derivative of e power x is e power x itself. You do need to know how to differentiate. Okay, so let's substitute everything in terms of u. Do we manage to get it everything in terms of u? E power 2x, we have u, and what is dx? As we're rearranging it, dx is actually du over negative e power x. Okay, so far so good. And here we have e power x, here we have e power 2x. We can simplify, so we are left with e power x square root u and du, and we do have that negative there. Okay, we need to have that negative, but yet up to this level you still have the x, right? Can we integrate up to this level? Cannot. It cannot integrate at. So you need to replace this e power u. So how? Where to get it? So we get from the assigned variable that we have just now. Okay, we assign u to be 1 minus e power x. We need to replace this e power x in terms of u. So here is easy. You can rearranging it such that e power x is 1 minus u. So substitute further. E power x is 1 minus u, and we have radical u. Radical u is actually u power half. Okay. So we need to expand, okay, before we are able to integrate. So 1 times u power half is u power half minus, here we have u power 1 multiplied by u power half, 1 plus half, which is u power 3 on 2. Up to this level, alhamdulillah, you can now integrate. Up to this level, cannot integrate. Okay, cannot, sorry, integrate. I meant to say integrate. Just now I mentioned differentiate. Cannot integrate. You cannot integrate with two variables. So let us integrate. Okay, now we can integrate, right? So negative using a formula of what? X power r. Okay, variable power constant. X power r plus 1 over r plus 1. So check my work. This is u power 3 on 2 over 3 on 2. Flip it straight away. Okay, here we have minus. This is actually the whole set being minus 1. Minus should be, if we take it outside, minus minus should be plus. So u power 3 on 2 plus 1, 5 on 2 over 5 on 2. And don't forget your c. So sorry, the negative should be outside. Okay, we should make a bracket so that as we integrate, it has to be read as negative. As we expand the negative inside, this should be plus. Okay, inshallah. Alright, yeah, we need to replace back everything in terms of x. So as we replaced it, that will be our answer. So you all please try my work, okay? Especially on the signage. Power 3 and power 5. Okay, let us pause this video, okay, such that you should try first. Okay, question G, question H, and question I. Okay, pause the video and try these 3 questions before we are to compare answer. Okay, I will give you about 5 minutes. Alright. Okay, so here are the solutions. Okay, starting with GU being the denominator value, and differentiate and then substitute. Okay, we have to use in this case formula number 3. 1 on u du is ln u. U must be positive. And then you replace back in terms of x. Likewise, for the h, the appropriate u is on the denominator. Let u be 7 plus 4x. Differentiate. We need to replace dx here, which is du on 4. Before you consider to integrate, rearrange first, put your constant up front, and again integral over 1 on u is ln u, and then replace. Okay, as for the I, the appropriate u is inside the radical. Okay, so du dx, okay, 0 minus 4. Here we need to recall back on the differentiation of ln x, which is 1 on x. And here we need to replace dx over x. Rearranging this, dx on x is actually du on negative 4. Substitute. Okay, so read it as a power form. Put your constant up front. And then we use the formula of basic integral x power r. Okay, don't put your answer as like this. Okay, make sure that you flip this. Okay, 2 and 4 can be simplified further. So hence, and then replace the u. Right, so that will be your I. I hope you got it correct. And don't stop there. Make sure you do more exercises. So I would like to assign to you these simple class exercises. Do all of it, and then later try to compare your work with your friends. Alright, so that's it from me. Thank you.